Okay, vertex is the highest point on our parabola. There are two pieces. There is an x and there is a y. To this vertex, my x is going to be 0.5, 0.5, and our y value is 9. That is the highest piece. Okay? Our axis of symmetry is going to cut through the vertex. So if I cut through my vertex, that is at x is equal to 0.5. On the quiz you just got back, some of you forgot to put the x equals, so I wrote it on there, but I did not take points off. Okay? Tomorrow, please remember to put your x equals. It's a line. So x equals 0.5. That's where we're cutting in half. All right, our y-intercept comes from where we touch the y-axis. And where is that happening? At 5. And good, I heard someone say 0, 5. That's the point. It is a point at 0, 5. All right, and then the last piece, it was an x-intercept. So that's where we're crossing our x-axis. 1.25, yep, comma, 0. So y-intercepts always have an x0. X-intercepts always have a y0. It's good to remember because you'll use that when you solve for them with your equations too. All right, so we go with 6.1, observations from your graphs. All right, 6.2 was all about how many solutions are we going to have. Okay, to figure out how many solutions we're going to get, we use the discriminant, which was b squared minus 4ac. Okay, if we plugged in our pieces and we got a positive answer, how many solutions did we get? We got 2 real solutions, right? What if we got a negative number? No solutions. Good. 0 real. These are actually called the complex solutions. You might see that word. So 0 real or complex, it means the same thing. What if you actually got the number 0? You only have 1 real. All right, so that's what we're going to use for section 6.2. All right, so part A has x squared plus 9. Oh, what is it missing? It's missing the b, right? Could I put the b back in? I could, but with a 0. Yes, I could. If that helps you see it a little bit better. If you're missing a piece, you can replace it back with a 0. Because now, what's my A? A is 1, B is 0, C is 9. So we're going to do b squared, so 0 squared, minus 4 times my A of 1 times my C of 9. Okay, remember that 4 is always there. It didn't come from somewhere. It came from the equation. All right, that 4 will always be part of it. All right, what is 0 squared? 0. What is negative 4 times 1 times 9? So what is 0 minus 36? Negative 36. So what does that mean about my solutions? They are complex. I don't have any. Good. So we have no real solutions, which means they're complex. All right. My middle piece, x squared minus 18x plus 81. What is our A value? 1. What's my B? Negative 18. What's my C? 81. All right, so let's plug them in. And if you need to write like A, B, and C underneath it like that to help you remember what is what, do it. Will we ever plug in X? No. It is always numbers. It is always numbers. Okay? So b squared is going to be negative 18 squared minus 4 times 1 times 81. All right, what is negative 18 squared? This is what gets you guys. Is it 324 or is it negative 324? It'll be positive because look at that negative. It's inside, right? So negative times a negative will give me a positive 324. All right, how about negative 4 times 1 times 81? Negative 324. So 324 minus 324 gives me, bless you, 0. So we will have one real solution. Good. So again, if you have not done part 2 of your project yet, this will help you with that part. All right. All right, x squared plus 2x plus 8. I have A, B, and C. My color did not change like I wanted it to. There we go. Come on. A, B, and C. So I need B squared. So in this case, that's going to be 2 squared minus 4 times my A. Is A x squared? No, it is 1. Times my C, which is negative 8. All right, what is 2 squared? 4. Negative 4 times 1 times negative 8. Positive 32. So this gives me 36. Close. What do you mean? Negative 4 times 1 times negative 8 gives me the positive 32. Yep. So we have a discriminant of 36. So that means how many solutions am I going to have? I'm going to have 2 real solutions. All right. So again, 6-2 on your review will help you with part 2 in your project if you have not done that yet. Okay. Because it just worked out that way. All right. 6-3 will also help you with part 3 in your project. A lot of you skipped this. Okay. On your project, you pick the x values to plug in. Okay. A lot of you don't like that. You got a choice. You pick the x's to plug into your equation and tell me what they're equal to. All right. This one is someone jumping into a pool off of a platform that is 25 feet above the ground. Your height with respect to time can be modeled by the function 25 minus 16t squared. It wants us to complete the table. So did they give me the h or did they give me the t? Look at it. What did they give me? They gave me the t, right? They gave me time. So what they're wanting us to do is plug it in 25 minus 16 times 0 squared. Or 25 minus 16 times 0.25 squared. All right? When we're plugging these in, what are we going to do first? The subtraction, the multiplying, or the exponent?
The exponent.
We're always going to do the exponent first. And then what are we going to do?
Wait, no.
Then we're going to multiply. Then we're going to subtract. Okay? So we're kind of working backwards. So first things first, what is 0 squared? 0. What is 0 times 16?
0.
And then what is 25 minus 0? 25. Okay. I would, so you know where these numbers are coming from. Yes, if I write it, you should write it. That's called showing your work. Some of you still are having trouble with that. Showing of the work.
No, I thought that they
Okay.
were, I didn't see
Now, the next one. We have 25 minus 16 times 0.25 squared. So again, I'm going to show you your steps. We have to do our exponent first. So what is 0.25 squared? 0.25 times 0.25. 0.0625. All right. What is 0.0625 times 16? 1. All right. And then what is 25 minus 1? 24. So those are the steps we're doing each time. We're squaring, multiplying by 16, then subtracting it out of 25. So for this one, we got 21. Yep. I mean 24. Boop. Yep, I'm thinking of the next one. What is 0.5 squared? 0.25. Good. What is 0.25 times 16? 4. And what's 25 minus 24? I mean, my goodness. 25 minus 4 is 21. There we go. All right, 0.75 squared. All right, 0.5625 times 16. 25 minus 9. 16. 1 squared times 16. 25 minus 16. 9. Good. And spoiler alert, it's not on here, but I'll tell you, if we went one more, we would get 0. I know. Spoiler alert. All right, so now we have to create our graph. So we know that my y's are my elevation. Right? That's the feet. We know my x's are my time in seconds. I'm going to go ahead and label this with what they gave us. I wrote that too big. It's not going to fit. All right, so we have 0.25. We have 0.5, 0.75, 1, 1.25, 1.5, 1.75, and 2. The y's, I'm not going to count by 1 because they're not going to fit, right? I would like to count by 3. I notice a lot of those numbers are divisible by 3. So I'm going to go up 3, 6, 9, 12, 15, 18, 21, 24, 27, and I'll stop at 30. All right, let's plot my points. All right, when my t is 0, my elevation is 25 feet, so we're just above. When my time is 0.25 seconds, we're at an elevation of 24 feet. 0.75 seconds, we're now at 21. 1 second. I jumped, didn't I? What did I do? No, 0.75 is 16. Here we go. Do that right there. There we go. 1 second is 9. And I told you 1.25 is where they're going to land. Does this model someone probably jumping off of a platform into a pool? Yeah. Makes sense. All right, so that should help you with part 3 in your project, with plugging values in and getting an equation, getting the value of the equation out of it.
You said we have to type the story?
You're going to type the story. These are questions. These questions will help you write the story.
So you just said a whole page?
Uh-huh.
Like a word count or something?
Was what?
Is there like a word count?
Yep, so right here. It is, it's typed. times New Roman, font size is 12, one page double spaced. Yeah, good question. For your project part 7, you're using those to write your story. So how you answer those questions should be in your story somewhere. Okay? Alright, moving to the back. 6-4. Alright, we want us to graph the equation. 3x squared minus 6x minus 1. I'm going to go ahead and figure out my a's, b's, and c's, because we know I'm going to need them. Yep, a is 3, b is -6, c is -1. What do I already know about this parabola before doing anything else?
That the A value is more than 1.
My a value is more than 1, so it's going to open up, and it's also going to be stretched, right? Because it's a positive number more than 1. So it'll be opening up and stretched. All right, here we go. Identify the axis of symmetry. I've given you the equation. That's the x equals opposite b over 2a. Yep, that's going to be here. So opposite b, well, my b is -6 over 2a, which is 3. So what is opposite of -6? Positive 6. And what's 2 times 3? 6 over 6 is 1. That is my axis of symmetry. It is also the h part of my vertex. So I already have the first half of my vertex. That gives you 2 pieces there. So my axis of symmetry is on this dotted line somewhere, or my vertex is on that line somewhere. Alright, so if I have my h value, how do I find my k value? Plug it back in, yes. So to get the k of my vertex, we plug back in my h. Alright, so exponents first. So what is 1 squared? It is 1. Now we can do all my multiplying. What's 3 times 1? 6, -6 times 1. -6, and then -1. So this gives me what? -4. That is our k. So our vertex will be 1, -4. All right, y-intercepts. For a y-intercept, we make our x equals to 0. In standard form, it's also our c value, right? So what is my y-intercept? It's going to be 0, -1. I'm going to go ahead and plot the reflection point on the other side. So it's already pretty narrow, right? Which we expected because of that number 3. All right, x-intercepts is when your y is equal to 0. So regardless if it's standard or vertex form, we got to do the math here. Okay, so we're going to have 0 equals 3x squared minus 6x minus 1. Does anything multiply to give me 3 and add to give me 6? Nothing does it? Nada. It's just the way it worked out. This one is not factorable. So, what could we always use, though, to solve a quadratic equation? The square is not going to work. No, that's what we just said. The box is factoring. This is unfactorable. You cannot do it.
Complete square?
Nope. Quadratic formula works every single time. quadratic formula works every time. So, love you. Coming back. Here we go. So we're going to have x equals negative b, which is negative 6, plus or minus square root b squared minus 4ac all over 2a. Alright, what is negative? Negative 6. Positive 6. What is negative 6 squared? 36. What is negative 4 times 3 times negative 1? Positive 12. Good. And then what is 2 times 3? 6. So now I have 6 plus or minus the square root of 48 over 6. Is the square root of 48 a whole number? Square root of 49 is, right? That's 7. 48, just missed it. It's going to be a decimal, and it's okay. We're going to use the decimal. So to get our X-intercepts, and I'll tell you, I think it's 6.9. Someone double check me. 6.9. 6.92 something, something, something. Right. So we're just going to use 6.9. So we're going to do 6 plus 6.9 divided by 2, which gives me 2.15. And we're going to do 6 minus 6.9 over 6, which gives me negative 0.15. Oh, I should have divided by 6 on both of them. Thank you. Yep, because that's 6. Thank you. So my intercepts are 2.150 and what is it? Negative 0.150. So barely here and barely there. We have a very narrow quadratic function. If we could factor, we would use the box, right? This one was not able to be factored, so we did quadratic formula. Yes. 6.4 helps you with project part 4. So if you have not done pieces of that yet, what we just did will help you with part 4. Six 5 will help you with part 5. I know. Are we good? Anyone need any of that before I move on to 6.5? Well, you gotta plot the points that we just found. How is 6.5 different from 6.4? We're still graphing. What did they, look at what they gave me. It's Vertex Form now. Yeah. I personally like better. Here we go. 6.5. Right? They have given it to me in Vertex Form. Let's remember what Vertex Form is. That is y equals a, x minus h squared, and plus k. That is the Vertex Form we're going to be using. Technically, yes. But we use h to represent any, we use x to represent any x value. H is a specific x value in my vertex. Does that make sense? Alright. Identify A. So what is A in this one? A is -1, so are we going to open up or down? We're going to open down. I can also go ahead and answer the part E, right?
Yeah.
Since A is -1, is it going to be stretched, compressed?
Semi-compressed.
Kind of a trick question. It's neither.
Oh, that makes sense.
It's neither. Stretch would make it be a 2, 3, even a -2, a -3. That's still a stretch. Compress is if it's less than 1, so like 1/2 or -1/2. Those would both be compressions. Positive or negative tells you up or down. Okay. Determine the vertex and the axis of symmetry and plot them. All right. Well, again, they gave me vertex form, so we like that. They gave me H and K. Here's my H. Here's my K. What do we always do with H? We change it. So instead of 1, it's -1. What do we always do with K?
Keep the same.
We keep it. So our vertex is -1, 4, which means my axis of symmetry is x equals -1. There we go. All right, find our Y-intercept. Remember, to find Y, that means x equals 0, right? Does vertex form give me that in the equation? No, only standard form does. Okay? Because I would need C, and there's not a C in my vertex form. So, make x equal 0. So it's going to be Y is equal to -0 plus 1 squared plus 4. We're making my x 0. All right, what is 0 plus 1? What is 1 squared? And there's still a negative out front, right? So what's -1 plus 4? 3. So our Y-intercept is going to be 0, 3. What can I also do right here? I can, before the X-intercept, I can copy the reflection point on the other side. All right, now let's find our X-intercepts. And X-intercept comes when your Y is 0. So we're going to say 0, so now we're making this piece, equals -x plus 4 squared plus, oh my goodness, that should be a 1. Here we go, plus 4. All right, what's first? Subtract the 4, good. So we have -4 equals -x plus 1 squared. They both have a negative in front, so can I take it away from both of them? Yes, I can. That's like dividing by a negative. So I can make this now +4 equals x plus 1 squared. What's wrong? Because I divided each of these by the -1. Yep. How do we undo a square? Square root it. So that gets rid of my 2 over there, my little exponent. But square root of 4 is now positive and -2. Equals x plus 1. We should have 2 X-intercepts, right? So when I subtract the 1 over, we need -1 plus 2, and I need -1 minus 2. So that gives me a +1 and a -3. I subtract the 1 over. Like if you did that. Yeah, so it's going to be the same thing. So that would be 2 minus 1, which is 1. It's also negative 2 minus 1, which is negative 3. So you should get the same thing, yeah. All right, and then here's our parabola. Boop. Questions there? Are we feeling better about this? Kind of? Okay.
Wait, so we're not doing these?
I'm not done yet. Yeah, we're doing the bottom. I'm just not done. I just wanted to see where y'all were at. Ready for 6-6?
Mm-hmm.
So again, 6-5 is going to help you with part 5 on your project, okay? So the only thing that's on your project that's not on this is your domain, okay? Domain and range. Your domain, guys, are always all real. Your range is attached to your vertex. So here, my vertex, range means y, I'm looking at the 4. Is the entire parabola above or below that y of 4?
Wait.
This is 4, right?
Oh, it's above.
All of my y's are
Oh, no.
literally underneath the 4, right? We're below the 4. So the range for this particular problem would be all the y's are less than or equal to 4. Okay? So on your number 5, you should be looking at your vertex to help you with your range. Okay? All right. 6-6. Here we go. We did this yesterday. We have x squared plus 12x minus 32. They want me to get it in vertex form and then identify the vertex. So remember, vertex form is y equals a x minus h squared plus k, right? Our vertex is hk. So that's what it's asking me to fill in. So I obviously need my a, my h, and my k. Standard form already has a part of it, right? So we know a is what? We know a is 1. Boom. Yeah. We know a is 1. How am I going to figure out my h? Look behind you. Look behind you. There it is. The negative b over 2a. Yep. Opposite b over 2a. Yeah. Yep. Same thing. No, you're right. So h is opposite b over 2a. I like saying opposite. I think it connects with people a little bit better. So my b is what?
It's 12.
Okay. It's just 12. It's not 12x. Never ever plug in x. Don't ever do it. Okay, we're plugging in numbers. So opposite of 12 over 2 times 1. That gives me negative 12 over 2, which is negative 6. That is our h. So I know the first part of my vertex is negative 6. What do I put into my equation? I have opposite h. So what's going to go in there?
Positive 6.
Positive 6. All right, and how are we going to find the k piece? Plug it back in. So k is going to be negative 6 squared plus 12 times negative 6 minus 32. What is negative 6 squared? 36. What is 12 times negative 6? Negative 72. Good. All right, so 36 minus 72 minus 32 gives me negative 68. So that is our k. So in the equation, do I change it? No, we keep the k. Keep the k. So there's my vertex form of my equation. And then over here, negative 68 is my k. So there's my vertex. Yep, change the h and keep the k. And what helps me, because you know I'm my visual self, there's actually a letter h in the word change, right? Change your h. And then the word keep has the k. Keep your k.
So hard to write on that?
Different parts of the tablet are like that corner is not a good corner.
Yeah.
But my top corners were fine. So different pieces of the tablet are more sensitive. All right, that is Unit 6 altogether. All right, and remember, it's going to help you also with your project. So project part 6 last night goes with 6-6 on your review. Okay, so this test review is going to help you get ready for your test, obviously. It's also going to help you with your project. Okay, so if you need it for your project, use it for your project. Yes, ma'am. Okay, so the reflection point just means our Y-intercept will always be a reflection point because it's like this was one point on the right of the axis of symmetry, so I can go one to the left of the axis of symmetry and get the other point. So you're just reflecting it across that middle dotted line. So whatever distance you are away from it, do that same thing on the other side.